Good morning, everybody. In the today's class of operational research, we'll be discussing regarding the failure mechanisms of replacement theory. In the previous class, we have been discussed related to the three different conditions and leads towards the replacement of a particular machinery upon its maintenance cost basis, timely basis, as per the conditions that are being specified that annual maintenance cost should not be greater than the initial input cost. If it is greater than in nature, simultaneously the replacement is necessary for that machinery. And if at all it is less than that, furtherly it can be extended for the utilization until it reaches or equilibrium state with respect to the average maintenance cost per year to the total input cost of the machinery. And rather than that, there are additional more calculations or points related towards this replacement criteria upon different mechanisms in the working environment that is particularly related towards the manufacturing industries, production industries. That is nothing but depending upon the loading criteria, the machineries will be getting failure in condition upon the gradual strategy or prolonged status of strategy, that is nothing but progressive strategy, or suddenly failure may be getting occurred. So we'll be looking on related to those kinds of categories in the today's session. Initially moving on to the gradual failure. So the gradual failure is nothing but the mechanism which is progressive. That is nothing but life of an particular object or particular machinery increases, its efficiency deteriorates due to the following reasons. So the life expectancy is calculated or increases depending upon its factors. Just will be discussing this, and depending upon that, the efficiency of the machinery will be getting deteriorates because increasing in expenditure for operating costs, the efficiency has been in minute in nature. Obviously, the expenditure will be very much increasing in the case of this maintenance leads and hence leads towards the replacement of that particular item, and even decreased equipment's productivity. Nothing but if the machinery got gradually decreasing in its efficiency, obviously it leads towards the less work performance. Hence, the less work performance leads towards the decreasing in the production also as well. For example, within 1 hour, you have been for an initial strategy or normal working mode containing machinery manufactures a 5 to 6 number of items. When the efficiency got decreased, it will be leads towards the manufacturing of 3 to 4 different types of items. Hence, the main variation is 2 to 3 products on that machinery. Hence, in day to compensate with that, we need to install another one more machinery, or else has to replace with it. And when that replacement is necessary, we had a detailed discussion in the previous classes. And another one more parameter it is decreases in the value of the equipment. Nothing but resale value, as we have been discussed in the previous class, that the resale value of the equipment will be completely decreasing as per its performance criteria. Nothing but if the efficiency has been decreased, obviously the equipment value also will be very much decreased. That is nothing but the resale value. So, what are the different kinds of things that will be coming under this category? So, n number of machineries which are working in the domestical criteria, in the industrial fields, in the medical fields, then A to Z fields that are existing in the global wide. Machine tools, flexible manufacturing equipment, etc. Moving on to the sudden failure. So this type of failure or occurred in the items that do not deteriorate markedly with the service orientedly, depending upon the time factor and based upon the conditions. This will not be applicable in the case of this sudden kind of failure. Ultimately, failure will be taking place on a sudden upon utility of that particular material for a particular time period. So it will be working for a while to some extent or to a particular time period, and suddenly without any intimation we will be getting failed ultimately. So here ultimate leads to an compulsion. So if you have been considered any type of equipment, particular type of the equipment, the period from installation to failure will not be equal. No, it's not equal, but will follow some frequency distribution, which may be progressive or retrogressive or random in nature. Nothing but it seems that even the lifetime for that particular product at the initial stage has been specified while manufacturing by the company experts or analysts that the object will be existing for a period of 3 years or 4 years. No, it's not about the lifetime of that particular product is for about 3 to 4 years. But due to the heavy loading conditions, or whatever it may be the reason in the manufacturing field that we have been considered, repeated usage or heavy load application than the allowable limitations leads to a formation of over stresses and maybe getting failed. There is ultimately. So that is nothing but the random in nature. That is called a sudden failure category. Moving on to the progressive failures. In the mechanisms, probability of failure increases as the life of the equipment also increases. Coming to an examples that electric bulbs, automobile tubes, etc. Those are nothing but the utilization factors will be directly linked with respect to the utilization factors or the type of utilization, the type of loads that are being required. The heavy loads, uh, for an instance, if you have been considered when you have got you have gone to an electrical shop that you need to purchase a bulb, he will be giving an that warranty date. So if it has been got failure, he will be getting replaced. And after that, so it, he will be giving 1 year of warranty or 6 months of warranty, whatever it may be. So when it has been, suppose you have been considered 6 months of warranty, it has been entered into the seventh month. The lifetime has been expired, nothing but that particular bulb has been got failure without lightening, then we can't approach him for the replacement. And now obviously it has been increased furtherly even after crossing, even the lifetime has been given for about 6 months. After crossing 1 year also, it is continuously in a working condition itself. There is nothing but the type of utilization plays a major important role here. So that specifies the progressive failures. So maybe in increasing strategy, or else in the decreasing strategy, or else among the 40 different kinds of electrical rolls, only the 20 to 25 will be in a replacement category, and rest of them are in the working conditions with a full efficiency. Or else maybe only 10 to 15 are considered under the failure conditions or replacement conditions, and later on remaining overall 25 to 30 bulbs or in as it is working conditions, even the life expectancy time period has been crossed over. So there is a, we can't say that it will be depending upon the environmental criteria. So those are nothing but the progressive failures. Coming to the point of retrogressive failures, some equipment are prone to get failure with high probability in the beginning of their life, and as the time progresses, the probability of failure falls down. This is the condition that have been discussed just now. Even though the life expectancy has been given, after crossing it also, it doesn't fail. So among the just we have discussed the following example in the cases of this E, B, and even the C. There is nothing but retrogressive failures, progressive failures, or random in failures. So those will be coming under the sudden failures. We can't say anything that whether it may be working in a simple solutions. Nothing but within the time period specified, only it may get failure within that 6 months of time period, or else after passing 6 months also it will be in continuously working mode, or else rather than that, in the random conditions of failures within the 6 months, maximum 80% to 90% of the bulbs may get failure, and 10% may be in the replacement. In such a criteria, it will be getting followed. So even after the lifetime has been expired, there will be in continuous working motion. Majority of the objects will be in continuously working position. That will be coming under the retrogressive failures. Going to the point of these random failures, the constant probability of a failure is associated with the equipment that fails from random causes such as physical shocks, not related to the conditions of this age criteria. Only in examples, electronic components such as transistors, diodes, rectifiers, conductor elements, brittle different kinds of brittle elements, and even perishable items like fruits and vegetables. Who doesn't know? Even we have been kept in an away from the algae or bacteria in the refrigerator also. It will be getting failed when it has been reacted. Vegetables or fruits when they have been reacted with respect to the H2O, nothing but the water. So the dry conditions they will be getting existing within the refrigerating conditions or temperature that is maintained within the refrigerator. Rather than that, even at that temperature, if you have been maintaining a similar strategy, obviously they will be getting fine. So these are nothing but these are coming under the random criteria. That is, there is a one shot of a probability that is related towards the failure category. And for these different kinds, what are the types of replacement existing among the discussed criteria? In what type of replacement different kinds of related to the different kinds of situations we have to follow, and I have to step in for the estimation of time without any change in the money value. So, related to the first kind, replacement policy for item deteriorating gradually with use of time. So, without change in the money value, but only with the use of the time. Depending on this, here it is a time constraint. Second category, replacement policy for items deteriorating with time, but the money value also changes. Nothing but a resale value will be getting decreased gradually. That is the second condition. So first condition is money will be an constant, as you've been seeing in the last class that input cost will be same strategy, even though the failure of that particular item has been happening, the initial input cost will be as it is throughout that lifetime period. Secondly, it is an replacement, that is an expense or money value also will be getting changed. This is nothing but the resale value is getting decreased or changing. Third one, it is replacement policy of items breaking down suddenly. Either it may be happened within that machinery, either individual replacement policy or group replacement policy. So individually, only in that particular product leads to an high expenditure, or group wise it will be moving on with respect to an less expenditure, as have been discussed in the previous sessions. Next one is staff replacement. So we'll be looking after one by one kind. Replacement problems. First methodology. The policy for item deteriorating gradually with use of time without changing the money value. Considering the questionnaire, a mill owner finds from his past records that cost of running a machine which purchase whose purchase price is rupees 7,000 are given below. So initial input cost of that particular machine is 7,000 rupees. Considering as a rice mill or whatsoever, like dal mill or rice mill whatsoever. So the initial input cost is 7,000 for this, and the year-wise running cost or operating cost or maintenance cost is being given for it, and variation with respect to the resale value also being given towards it. Upon utilization, will be getting decreasing in its efficiency as we have been discussed in the previous uh, 10 minutes before in the initial of this class. The resale value also given here. So the operating cost in the first year it is 900, the second year it is 1200, the third year it is 1600. So nothing but an incrementing of 300 from first year to second year. So it leads to an additional of so in an overall financial year or else the academic year, that machine utilizes 900 rupees for its working. In the second year it utilizes 1200. So increasing with the 300 in the second year. So 9 plus the 1200 in the second year. So in the third year it is 1600. Fourth year 2100. Fifth year 2800. Simultaneously looking after the resale value. Initially it is 7000, and after crossing 1 year that is 4000, and for 2 years it is 2000, 3 years 1200, 4 years 600, 5 years 500, and 6 years 600, 7 years also 400, sorry 400, and 8 years also 400. So constantly maintaining of resale value at sixth year. From sixth year onwards, it is constantly maintaining the similar resale value. So when it has to be replaced, so we are also having some of the conditions discussed earlierly, that the basic relation towards it will be having a detailed look. Here the condition it is the given data capital cost 7,000, operating cost that is M, resale value that will be considering ES, that has been given here M, and next the resale values as per the table of column specifiers that will be. identifying here. And we all know that time is t is time and n is a number of years after which the asset is to be replaced. So at n conditions after n years it has to be replaced. So what is the n value that need to be analyzed here, right? So we are also having the conditions that when the operating cost that is being increasing than the capital cost in such a year will be identifying naturally the operating costs or total average cost that are expenditure, maintenance expenditure that is being spending on that particular machine. If it crosses the total capital cost of the machinery, obviously it needs the replacement. So in the present given problem, at what time or at what position it will be replaced, we will be having a detailed discussion. So considering this tabular column here, the operating cost per year it has been specified. Here t relates towards the time, and the time has been given to by in the period of a year in our problem, and this cumulative operating condition has been considered, and resale as per the given tabular column or in the question. Next one, the depreciation. So what is the depreciation value? That is nothing but the operating cost minus the overall resale value, and the total cost will be identifying here by the addition of this depreciation cost and with respect to the cumulative operating cost, and average will be finding out with respect to the term basis, that is in time, that is time relates towards year in our problem related to the per year. So initially we are considering from the given question that is 900, 1200, 1600 per year, and the resale value 4000, 2000, 1200, like that. So initially first condition is 900, cumulative also 900, there is no any additional charges over here for the maintenance, and resale value is 4000, and this depreciation cost here it specifies 4000 relates towards this depreciation cost. Question is total cost minus the resale cost. So total cost here it is of the machinery 7000. So 7000 minus 4000 it is 3000. Next total cost, that is 3000 plus this relative cost 3900. So average per year divided by 1, that is 3900. Simultaneously, if you have been considering the second year, the operating cost is 1200, and cumulative cost in the sense is first year 900 and second year is 1200. So 500 plus 1200, 2100, and the resale value it is 2000 given for the second year, and the depreciation cost here specifies this 7000 total cost minus total loss of the equipment minus the resale value 7000 minus this 2000, and here specifies the 5000, and total cost for 2 years for n here n specifies the time. So 2 years, and hence 5000 plus 2100, 7100 is the value total cost, and the average cost for about 2 years it needs to be counted. So 7100 divided by 2, that is 3550. Coming to the third year, the operating cost is 1600 given in the question, and resale value is 1200 given in the question, and calculating this cumulative operational maintenance cost, that is 2100 to 1600 for 3 years. So it is 3700 the value, and the depreciation cost. So initial cost is 7000, 7000 minus this 600 resale value for the fourth year, and 6400, and the total cost is 6400 plus this cumulative operating cost 5800, leads to 12,200. And the average cost here for about 4 years, 12,200 divided by 4, that is 3,050. Alright. And simultaneously for the fifth year, it is operating cost 2,800 and resale value it is 500. And moving on to the cumulative operational cost, 5,800 plus 2,800, that is 8,600 for about 5 years, fifth year. And moving on with respect to this depreciation cost, 7,000 minus this 500. 7,000 minus 500 resale value, that is 6,500. So the total cost of operation is 6,500 plus 8,600, that is 15,100. So 15,100 divided by, that is n number of time periods. That is how many years? N relates to time period, 5 years. So 15,100 divided by 5, that is 3,020. 3,020. And moving on to the sixth year, that is operational cost 3,700 and resale value is 400. And the cumulative 8,600 plus 3,700 is 4,300. And simultaneously here the resale depreciation cost 7,000 minus 400 of the resale value, that is 6,600. And this is similar for overall. Only the cumulative values upon addition will be adding for the rest of the cadres. And simultaneously we will be adding in the total cost. For the total cost is depreciation cost plus the operational cost, average operational cost, including all the expenses. All the expenses, there is sigma, all the expenses. It leads to the value, and upon division of this value for the n number of years, which is for 7 and for 8, we will be getting the corresponding average cost values. So here the total cost expenditure will be identified. So moving on to the initial strategy, coming to the operational cost. So the main formulation for it is the operational cumulative operational cost. So cumulative operational cost, where it has been including the overall charges, that is sigma, should not cross the initial cost of the machinery, 7,000. So where it is crossing? For fifth one, it is crossing. For fourth one, is 5,800. So initial cost of the machinery is 7,000, and for the fifth year, it is 8,600. 7,000 only the input cost of the machinery. So 8,600. It crosses the condition. So when it has been crosses the condition, the conditions will not be applied furtherly. So hence replacement is necessary. And in the fifth year, as per the tabular column specifies that the total cost is being crossed away with respect to 8,600, whereas the capital cost of the machinery is only 7,000. So we're having that cumulative operational cost when it has been crossing the capital cost, then it should not be in feasible conditions. So that is nothing but the life expectancy or efficiency of that particular machinery is very much less when compared with respect to the previous years. So if the efficiency condition here it is clearly specifying that if the efficiency of that particular machinery is very much less than the previous year, no, it is quite increasing than the previous year. In the fourth year it is 5,800 only, and in the fifth year it is 8,600. But so it is 8,600. Even if it is 6,500 or 6,700 range, such a criteria, it is greater than the previous year. So it is not less than the previous year. That is the condition one that fails in sustenance condition. Second one, it is capital cost condition. So second condition will be maybe preferring for that 1 year. It is if it is 6,800, is 200 very much less when compared to the capital cost, and hence it is a valid point. So in such a criteria, we will be accepting that one. So other than that, there is a non-conditional strategy. That is overcrossing this capital condition, and when compared to the previous year maintenance, it is very much greater, and which crosses the input condition, input cost also, or capital cost also. And That particular situation happened in the fifth academic year or fifth financial year. So that fifth financial year on an average cost of 3,020 rupees. And the question is clearly specifying that the average or minimum average cost, that is 3,020, and the replacement is necessary as per the conditional strategy at the end of the fifth year. So that is the third one. And moving on with respect to the second criteria, that is replacement problem or policy for items deteriorating with time, but the money value also changes. So previously money value we haven't considered. So in the second condition, we are considering this money condition also. So in this, the original cost of the machine is 5,000 rupees and varies with respect to cost variations. So first one it is one, and previous year, in the previous problems we have been seen that the operating cost also given, and next the resale value also given. But here the resale value doesn't specify, because with operation cost it will be getting varied with respect to the time basis, that is year wise. So operating cost only will be given, and that the resale values or conditions without that hint also will be considered as a constraint and that need to be specified, right? So the additional strategy for this solving of this problem, given that at 9% is the discount rate of money, 9% is the discount rate of the money, what should be the optimum replacement interval? So what should be the optimal replacement interval? So here it is given that in the percentage criteria. So what percentage the discount rate of this money, an optimal replacement is necessary. So that will be having a clear cut look based upon the percentage criteria. Will be measuring the with respect to this previous value at the rate of 9% for each and every criteria. First one, the operating cost or original cost or investment cost is 5,000, and the scrap we cannot find out, and hence we will be considering it as zero. Resale value is not given, and hence it is given to resale value given, that will be considered as an scrap, and scrap also will be getting to a particular value. The value doesn't given to us, and hence it will be equal to the zero. So considering the deteriorating conditions, so optimal replacement, and we are following the similar strategy of condition. First one, it is only the operational cost in the question that has been given 400, 500, 700 for third year, 1000 for fourth year, 1300 for fifth year, 700 for sixth year, and seventh year it is 2100. So we have to formulate with respect to 9% of discount rate of the money related, economical related, and have to solve the problem. So first one it is 400, 500, 700, 1000, 13, 17, 21. So here operational cost will be in common in criteria. So cumulative we have to follow only depending upon the cost value. So cost value also given with respect to previous value, then a rate of interest. So rate of interest here it is 9%. Here it is 9%. So we'll be including with respect to this, and maximum maintaining conditions will be getting add on with respect to the percentage criteria, right? And depending upon that, we will be finding the depreciation value and addition of this total value with respect to the cumulative maintenance plus the depreciation value, and comparing this cumulative PV value, previous value, and depending upon that, weight percentage will be calculated. Weight average will be calculated. So that average value will be identifying with respect to two conditions, and the previous one is the value or cost effective is constant and operational cost is getting varied. And here the operational cost is constant, the value is varies by a percentage. So first one it is operating cost 400, and it has been entered vice versa for 7 different years or the financial years. And the PV value, the 9% is initial it is an 1, and sigma of maintenance cost had been considered, it is 400, There's no any change. 400 by 1, 400. And overall maintenance cost is 400, and the depreciation cost, initial cost is 5,000, and entering the same condition 5,000. There's no any uh, resale value, and hence resale value is equal to 0 for initial condition. 5,000 minus 0, that is 5,000. And the total cost, overall cost, that is maintenance cost 400 plus depreciation cost 5,000, upon addition 5,400, and cumulative value is 1, this 1, and hence this 5,400 divided by 1, and the average value is 5,400. Moving on to the year number 2, we already have the operational cost for the second, it is 500, right? So percentage criteria, if you can consider for the second year, the 9% rate of interest has to be calculated. That leads to 0.917. So the sigma value of this PV, that is 400, sigma value for its consideration is as per the criteria as follows. So 9% is related value, and the multiplication of this value of 500 into 0.917 leads to 458.5. Here clearly specifies that 9% of the yearly value is considered. So 4,001 is 400, and 9% has been added towards it. So 500 into 9 percentage, that is 0.917. 500 into 9 percentage, 9 percentage value, it is 0.917. So 500 into 0.917 leads to 458.5 value. And cumulative of these maintenance charges, so for 2 years, so initial first year is 400, and second year upon calculation it is 458.5. So 458.5 plus 400 is 858.5. And depreciation, there is no any value determination. So determination, there is no any change in the value because the resale value is considered as 0, and hence 5,000 will be common for each and everything. So 5,000, and the total cost here, total cost might have been considered 858.5 plus 5,000, 5,858.50. And coming to the cumulative point of view, cumulative point of view, here it is 1 for the first year, and second year it is plus 0.917. So hence it is 1.917. All right. So upon conditioning of this average weight value with respect to the accumulating value, here the average value for each and every year after consideration leads towards the cumulative value. So 1.917. So the total cost value divisible by cumulative value leads to the total average value. For about 2 years, it is the cumulative value. So initial first year it is 1, and second year it is 0.917. So we have taken cumulative for 2 years, it is 1.917. So hence the total value for 2 years 5858.5 divided by 1.97 leads to the 3056 value. Commonly the third year it is 700, and 9% of interest, that leads to 0.841, and 700 into 0.841 leads to the 588.7 value, and this sigma mt leads to 858.5 plus 588.7 third, that addition leads to 1447.2. The determination value is similar 5,000, and the total cost here it is 6,447.2. So 1,447.2 plus 5,000 is 6,447.2, and the cumulative PV value it is 1.917 plus for the third it is 0.841, and leads to 2.758. So the total cost divided by 2.758 leads to 2338 value. Commonly the fourth value also taken, fifth value is also taken, sixth value, seventh value, and we'll be proceeding with the seventh value endingly 2100 here as per the given questionnaire. It is 2100 in the seventh segment. And in the seventh variation of 9% of value, we are getting 0.596. So 2100 into 0.596 leads to 1251.6. The sigma value here leads to here, before value, before here is 4244.6 plus 1251.6 leads to 5496.2. The determination value is common throughout the period, that is, hence the resale value is 0. Hence the total cost, it is 5000 plus 5496.2, that is 10,496.2. The average value or cumulative value of PV is 4.888 in the sixth year, and seventh year it is adding of 0.596 leads to 5.484, and endingly 10,496.2 divisible by 5.484 leads to 1914 value. And we have to be noticed that the maintenance cost, so here the maintenance cost specifies, so the total original cost of the particular good has been given by 5000, and it should be the beyond the limitations of the total maintenance cost. So in the sixth year, it have been considered 4244.6. Hence, it is less than the total original cost of the machinery. Considering the seventh year, 5496.2 cumulative. So it is crossing the total cost, that is 5000. And hence, it is not feasible or accepted anymore. Hence, in the sixth year itself, it is considering in the sixth year. In the sixth year itself, the replacement is necessary. And the average weight or cost, that is related to 1891. Maybe of it is considered in the weight, it is considered in the cages, or else the economical basis or cost basis, it is considered as a rupees strategy. So, hence, our prescribed answer is, since the average cost of sixth year is less than the average cost of the seventh year, so the optimal replacement at the end of the sixth year is necessary. And even the second valid point, it is when compared to the sixth year is very much less when compared to the seventh year. Seventh year is very much greater. So here it is sixth year, seventh, and compared to the seventh year, it is very much less increasing in strategy. So that's the one condition, and depending upon this maintenance, overall maintenance, sigma, this overall maintenance of the machinery should not cross the original cost of the machinery is 5000. Hence it is being crossing together. Hence it is not feasible. Replacement is necessary earliest in the sixth year itself. In the seventh year, it can be considered. Alright. And replacement problem number 3, that is regarding the policy terms of a breakdown, which is happening suddenly, progressively, and intermittently. And the probability ratio we will be discussing in the next class. Thank you.